Good morning, everyone. So let us start our topic today. So our topic is data communication and computer network. So today we are going to discuss the fundamentals of Dccn. So let us start from the first chapter very quickly. So you can see, let us understand first what is the meaning of the term data communication. So data communication is nothing, it is the transmission of digital data through an network. It is the basis of computer networks, and especially the students from computer science and IT required to handle data communication related problems. This subject enables to have insight into technology involved to make the network communication possible. So let us understand and go through in more detail. So what is the basic meaning of the term telecommunication? So the term telecommunication means communication at a distance. So the word data refers to the information presented in whatever form is agreed upon by the parties creating and using the data. Data communication means the exchange of data between two devices via some form of transmission medium such as wire or cable. So that means overall, we are just learning here how we are going to do exchange of information between multiple devices. So, what are the fundamental characteristics? Let us understand. So, the effectiveness of a data communication system depend on four characteristics. So, what are the characteristics? The first one is delivery, means it should reach the data or information or the packets must reach the correct destination. Accuracy, data must be accurately delivered what is sent by the sender. Timeliness, must deliver the data in timely manner. Jitter, variation in packet arrival time. So these four are the effective characteristics in a data communication system. So you can see this diagram here. This is the components of data communication. So you see this is the especially in the data communication we are dealing with two important components, sender and receiver. So sender, it is something here. Sender, this is a system here, and this one is the receiver, and this is the message we are sending. So we are using some protocols here, and at the sender side also we are using some protocols at the receiver side. So the basic terms we are using here is message, medium, sender, protocol, and receiver. So if we will um, tell it serially, it will be message, then sender, receiver, medium, and protocol. So what is a message? So message is nothing. It is the information or data to be communicated. Popular forms of information include text, numbers, pictures, audio, and video. Sender. The sender is the device that sends the data message. It can be computer, workstation, telephone, video, camera. Receiver. The receiver is the device that receives the message. It can be a computer, workstation, telephone, television, and so on. So, what is the transmission medium? The fourth important part. It is nothing, it is the physical path by which the message travels from sender to receiver. So, example of data transmission media include twisted cable, coaxial cable, fiber optics cable, and radio waves. So, what is a protocol? Protocol is nothing, it is a set of tools that manage the data communication. So, it is nothing, it represents the agreement between the communicating devices. Without a protocol, two devices may be connected but not communicating. Just as a person speaking French cannot understand by a person who speaks only Japanese. So here we are focusing on two points. First is communication between two devices. So maybe we are focusing on communicating between two devices here, sender and receiver. So first of all we are concerned about the connection, and once the connection happens properly, we should go for the communication. So what are the key elements of a protocol? Let us see. So the key elements are syntax, semantics, and timing. Syntax means the structure or format of the data. So you can see it's a diagram of a single simple protocol, right? So sender address is carrying 8 bits, receiver address requires 8 bits, and data is rest. And the total size of this message is here 64 bits. Semantics, it refers to the meaning of each section of bits. That means how a particular pattern is to be interpreted and what action is to be taken based on the interpretation. For example, we should know, does an address identify the route to be taken on the final destination of the message? For example, the last two bits of the receiver address contains 00, means sender and receiver are on the same network. So timing, what is the timing? Here P refers to two characteristics: when the data is to be sent and how fast it can be sent. For example, if a sender is producing data as at 100 Mbps, but the receiver can process the data at only 1 Mbps, the transmission will overload the receiver and the data will be lost. So sender and must send in 1 Mbps data and wait for acknowledgement before the next 1 Mbps of data sending. So let's go for some standards. What is the standards? So standards in the here basically falls into in data communication. The standards basically fall into two categories: de facto and de jure. So de facto and de jure. So let us see some of the standards and standards organizations are as follows: ISO, ITU, International Standard Organization, International Telecommunications Union, American National Standards Institute, Institute of Electrical and Electronic Engineers, IEEE, Electronic Industries Association, Internet Engineering Task Force. Largest national professional groups involved in developing standards for computing, communication, electrical engineering, and electronics. So here I have just shown you the description of one specific standard, that is IEEE. Similarly, we can also go for the other standards. So another is, we can say, Internet Engineering Task Force. One more standard description I have shown here. So it is concerned mainly with speeding the growth along with the evolution of internet communications. The standards body for the internet itself also reviews the internet software and hardware. So let us go for the bandwidth, data transmission rate, baud rate, and bits per second. So bandwidth is also called data transfer rate. So moving data from one point to another in a given time period is called bandwidth, and this is normally calculated in terms of second. Bandwidth is indicated by bits of data per seconds. So bandwidth is defined as the portion of the electromagnetic spectrum occupied by the signal. Bandwidth is the difference between the upper and lower frequency limits of the signal. For example, the voice signal ranges from 20 Hz to 20 kHz. So channel bandwidth of the channel is maximum frequency. It can allow to pass through it without attenuation and distortion. So digital bandwidth, this is the maximum rate that a medium can propagate through it. For digital devices, an internet connection via cable modem may provide 25 Mbps of bandwidth. And for analog devices, this bandwidth can be expressed in cycles per second on watch. So what is the beat rate? The beat rate is the number of bits sent in 1 second, usually expressed in bits per second. Okay, so bit rate is nothing. The number of bits we are sending in 1 second. For example, kilobits per second, kbps, mbps, megabits per second, gigabits per second. Okay, so this is the simple diagram I have shown here. So what is the baud rate? The baud rate is nothing. It refers to the number of signals that occurs per second. A symbol is one of several voltage. It can be a signal or symbol also changes also we can tell. So symbol is nothing. It can be a voltage, frequency change or phase change. So baud rate normally binary has two symbols, we know 0 and 1. In this case, the baud or symbol rate is same as the bit rate. However, it is possible to have more than two symbols per transmission interval, whereby each symbol represents multiple bits. So some of the here let us go for some formulas. So it is a bit, a unit of information. What is a baud? A unit of signaling speed. Bit rate, the number of bits transmitted per second. Baud rate is known as S here, number of symbols transmitted per second. General formula is B equal to S equal, where N equal to number of bits per second. So this is a comparison we have done here, right? So difference between bit rate and baud rate on the basis of 5 terms of comparison, that is basic definition, meaning, terms, bandwidth, determination, and equation. So let us understand it. So bit rate is the count of bits per second. Baud rate is the count of signal units per second. What in terms of meaning, bit rate determines the number of bits traveled per second. In terms of meaning, baud rate determines how many times the state of a signal is changing. Term usually used for bit rate is while the emphasis is on computer efficiency, here the data transmission over the channel is more concerned. Bandwidth determination, it cannot determine the bandwidth, it can determine how much bandwidth is required to send the signal. Equation, bit rate equal to baud rate into count of bits per signal unit. Baud rate equal to bit rate by number of bits per signal unit. So just here some simple problem. So you see, baud rate is the number of signals per second, bit rate is the number of bits per second. The formula is S equal to N by R, where S is the baud rate, N is the bit rate, and R is the bits in each signal element. In this case, 1600 signal elements are sent per second. So baud rate is 1600. So S equal to 1600, R equal to 5 here, and N is unknown. So here in this question it is given, you can see the first one here in this part, the signal carries 5 bits in each signal element. If 1600 signal elements are sent per second, find the baud rate and bit. So what is the baud rate here is 1600, and here the so S equal to 1600, R equal to 5, and N is unknown here. So if we can calculate S N equal to S into R, so 1600 into 5, that equal to 8000 bps or kbps. So therefore the bit rate is here 8000 bps. So, so here another question, number of bits equal to 8 and bit duration is 16 nanoseconds. So we have to find the bit rate. So bit rate equal to 8 by 16 that nanosecond, that equal to 0.5 into 10 to the power 9 bps, that equal to 500 mbps. So another question, an analog signal carries 4 bits per signal element. If 1000 signal elements are transmitted per second, find the bit rate. So we know the formula, R equal to 4 here, S equal to 1000, N equal to S into R, that is 4000 bps. So similarly here, another one, an analog signal has a bit rate of 8000 bps and a baud rate of 1000 baud. How many data elements are carried by each signal element? So N equal to 8000 here, S equal to 1000 here. So R rate, we have to calculate how many data elements are carried out by each signal element. So R equal to N by S. So this is 8 here. So next come to this slide, that is modes of communication, right? So communication between two devices, sender and receiver, can be of two types, simplex, haptoplex, and fourplex. So simplex mode means the communication is unidirectional. Only one of the device on a link can transmit. The other can only receive. Example, keyboard and monitor. So at a time, you can see in both of the case, only one of the device is transmitting and one is receiving. Hard-duplex. What is hard-duplex? In this mode, each station can both transmit and receive. When one device is sending, the other can only receive, and vice versa, like walkie-talkie. So both sender and receiver can send and receive, but data only travels one direction at a time. Okay. And in full duplex, both station can transmit and receive simultaneously. One common example of full duplex is telephone network. When two people are communicating by telephone line, both can talk and listen at the same time. So these are some of the diagrams of the simplex, haptoplex, and full duplex. So thank you. So let us stop here. Thank you, everyone.